Hi everybody, I'm Brent Shively, product and application trainer with Festool USA. In this video series, we're going to talk about building two types of cabinets, a frameless and a face frame cabinet. So stick along for the ride. A lot of you know how to build cabinets. I'm just going to show you some different ways to use the Festool product line to speed up the process, make it a little easier on you. So we'll talk about using the TS55, OF1010 plunge router, Domino, some of our sanders, Conturo, MFK 700 fixed router. For these cabinets, I'm just using some Baltic birch plywood and some poplar face frame material. Typically what I do is I'll start out with a design. I use a 3D modeling program, then figure out a cut list. Go through and sit down and try and maximize your material so you don't have any waste or very little waste. First step in the process is going to be break down our plywood. With the Festool system, you've got our TS55 and you've got our guide rails. We have a large variety of guide rails, as you can see up here. We also have a way of connecting guide rails. You can connect two guide rails, two shorter guide rails if you don't have space in your shop to store one guide rail or to transport one long guide rail. When they sell plywood, it's typically oversized. That is because the edges are not perfectly straight, they're rough, they may be damaged. It's also not square. I don't have a perfectly straight edge to reference off of to get my straight cuts. You can always use a table saw. That's definitely a way you can do it. What I don't like about table saws is they take up so much space. In my shop, I have a smaller shop, so the TS55 and a guide rail is perfect because it's just the footprint of the plywood that I need. I don't need in-feed and out-feed room like I would with a table saw. So I'm going to talk a little bit about the guide rail real quick. On the bottom of our guide rails are these two black strips. These are non-skid strips. So when it's on the material, by the time you get the weight of the saw in there, it's very difficult to move, which is what you want. You want to stay stationary. Also on the guide rail, we have this clear plastic piece. This is your splinter guard. This is what's going to keep the material from tearing up. Now obviously when we're ripping, we're not going to have that much chance of tear out. When we go to cross cut, that's going to be very important. Next thing we're going to do is get that straight edge on this piece of plywood. If you remember, we've got about a ½ inch on each side, so it doesn't have to be exactly accurate. I don't have to measure 1/8 inch down here, 1/8 inch down there. So what I do is I learned this tip from somebody else on YouTube. This is the limit stop that comes with the TS55, and it has a small lip right there. I'll use that lip, push it up against my splinter guard there, and down there, and now I'm about the same dimension all the way down. First couple times you cut with the guide rail, I recommend clamping the guide rail down, not just relying on the non-skid strips. On the underneath side of the guide rail, we can put the clamp right in, slide it up to the material, push it up, and lock it down. Do that on both ends, and now it definitely will not move. And we're ready to start making some cuts. Before we do that, there's a couple things we have to adjust on here, but to learn more how to do that, head over to our YouTube channel, and there's full videos on the complete setup of all of our saws for cutting on a guide rail. I prefer spending most of my time in the shop cutting and making things, not cleaning up after myself, so that's why I always use one of our dust extractors. Question I get asked a lot is the depth settings on the saw itself. If you look right here, we've got two different levels of depth setting. One says FS and the other one says nothing. This is an FS guide rail. What that FS stands for, that accounts for the thickness of the guide rail. So when I am on the guide rail, I want to set my measurement, whatever I'm cutting, to that. I'm cutting about 3/4, so I'm going to set it just one notch above 3/4. That'll cut through, but it won't cut through my table. Last step before we cut is make sure you have your safety glasses and your hearing protection. As I'm cutting, I'm running at full speed. I've got my depth set. I typically will put my hand under the hose, grab it here, let the saw do the work. So now that we've got a good reference edge ripped with the TS55, I can focus on my cut list. To make all these cuts, I could go back and forth and measure and mark and use a pencil and a tape measure or a folding rule. But I've found in my experience, that's usually when I make mistakes. The pencil line's on the wrong side, something like that. So I can use these parallel guides that'll help me stay more accurate. These parallel guides will do repeatable parallel rips or cuts. I'm not worried about squaring up the ends yet. I'm just want to make all my cuts parallel, then we'll square everything up later. I always push my first parallel guide all the way up against the material. I'll tighten the green screw down on the top, then don't forget to push that lever down on the bottom. And then I'll go to the other side. So I'll line the bracket up with the edge, then tighten the screw on top, the lever on the bottom, and now I can even up that gap, the same on both sides. All right, so next I have to set the dimension that I'm going to be ripping this to. I'm going to be ripping it to 580 millimeters. Now, for all you out there that don't use the metric system, that's okay. We have an imperial set of parallel guides as well. To set the distance, you want to make sure that you use this arrow right here, and I'll put it right on 580, and then lock that down. Same process on the other side. Find your 580, line up that arrow, lock it down. Now it's just a matter of pushing forward the guide rail, and now it's referenced at 580 on both sides. You're probably wondering if these come pre-calibrated. They do not. You have to calibrate them to your guide rail and to your saw. If you go to our YouTube channel, you can watch a whole video on how to calibrate the parallel guides and the parallel guide extensions. A lot of people think this is a very awkward cut. What they forget is that the saw is guided by the guide rail. I am just simply pushing it along. So what I'll do is I'll get myself inside the parallel guides to start, rather than starting out here, and after I start making my cut, moving around, I'll just start right here and then make my cut. Once that cut's done, I can remove my saw, slide my plywood out, and then I can just move the parallel guides to make my next cut. Next thing, I'm just going to reset my dimension for my next rip cut. Since I have this all set up and calibrated, it's just a matter of resetting this one dimension. Don't push on each end, just come to the center, push in the middle, and they'll get them both tightened up. All right, so I went ahead and I flipped the guide rail around because now I need to switch my rips down to 75 millimeters. To do so, I'm going to have to change my stop from the parallel guide over here to the parallel guide extension, because the parallel guide stops at about 190. The extensions go all the way down from 230 down to 0. So I can set that at 75. Lock that into place. Do the same thing on the other one. Getting ready to do some cross cuts here. I just wanted to let you know that I changed the blade. I had a 28 tooth ripping blade on there from prior. I just put our 48 tooth finish blade that comes with the saw. Another thing I'm going to change out, I'm going to change from our clear plastic viewing window to one of our splinter guards. Because before, when I was cutting, for one, I was ripping, so there wasn't a lot of tear out. And two, now I'm going to have two pieces of material that I want to cut, and I'm cross cutting. Like I said before, when you're cross cutting, there's more chance of tear out. So now we have a splinter guard on the outfeed side of the blade and a splinter guard on our guide rail for the inside of the blade. So before we start cross cutting, I want to talk to you a little bit about the MFT setup we have here. All these parts and pieces that you see come with our full MFT set. I have a whole setup video on our YouTube channel that walks you through the process, shows you exactly how to square it up, how to set everything so that it allows you to do repetitive cuts over and over again. I always like to work smarter, not harder. So the first piece I'm going to do is about 768 millimeters or 30 1/4. I'm actually going to cut it quite a bit longer. Well, not quite a bit, about 1/4 inch to a 1/2 inch longer. And I'll show you why here in a minute. So I got my mark. Set this up, slide it down to my pencil line. Now that I have that cut to length, I can just flip it over. Got my square end on this side. Now I just have to clean up this edge to the exact length. It's a lot easier than flipping this whole entire large piece over. I'm just working with a smaller piece. So I'll come back, get my exact measurement. Now I can line that up. Now I can slide this piece all the way down. I know these two pieces are going to be exactly the same. Those will be my base cabinet sides. For this one, I'm going to cut it a little bit shorter because it's going to be the middle of my cabinet. Now I have my two sides and the base, the bottom for my base cabinet. So now we're going to walk through the same process, but with the pieces for my upper cabinet. Because the sides for my upper and lower cabinet are going to be the same height, I can utilize the same stop. Get it close, cut this end, flip it over, and square it up. Flip this piece over, lower my flag stop, cut it to length. Now I'll cut the top and bottom for my upper cabinet. Okay. Now the sides and the bottoms for my upper and lower cabinets are all cut to length. So now that we have all of our sheet goods cut down, cut to size, ripped and cross-cut, now I can start on the face frame for the lower cabinet. I've already gone through the step of ripping my poplar down to 50 millimeters or about 2 inches. I could utilize the MFT to do all my cross-cutting here without an issue. I'm going to choose to use the Capex though, so we'll show you how to do that. All right, so to break down our hardwoods for our face frame, it's along the same process as the plywood. I've ripped my 2 edges. I've ripped this material down to 50 millimeters or about 2 inches. Now I need to make sure this face is square to this face. To do so, I'm going to use the Capex, get my material in here. I'm going to turn my laser on, and that laser tells me exactly where that blade's going to cut. I've got a line on either side of the blade, so I can line that up, get that set, and then use the clamp here on the other side that comes with the Capex. So I press it down, lock it into place, it's easy. Then I'm ready to cut. Cutting is as simple as pulling this trigger up, that allows me to bring the head down, and this is your power. Now, if you noticed, I let the blade completely stop before I raised it back up. We're all guilty of not doing that. Try and do that. I don't care if it's a Festool or another brand saw. It helps from keep that material from kicking out the back. So next thing I want to do is go to my cut list, which I've got listed in metric and imperial. Find the number that I need, which is 7/68 or 30 1/4. 30 1/4, I've got an imperial scale on here. You can also get the extensions in metric as well. So I can find 30 1/4 with my flag stop, lock that down. And I know that's going to cut exactly 30 1/4 inches because I've calibrated these extensions. Calibrating the extensions is very, very easy. If you go on to our YouTube channel, you can find out more information about that. So once I have that on, I can slide that over. Now, there's something I want to show you. If you can see right here, when I put the poplar up against the fence of the Capex, there's now a gap from the fence on the extension to the poplar. That's on purpose. I don't want that perfectly flush with this. It's because my poplar may not be perfectly straight. It may have a bow to it. I always leave a gap in there. Some people do, some people don't. I've found that if there is a bow, it could bind up on the blade and cause kickback. Next thing I want to do is move my clamp to the other side of the Capex, because I want the clamp on the same side as my flag stop. Once I have that all lined up, I'm ready to make a cut. And I see that I need 2 of those, so I can just slide the next one down, lock it into place, put my clamp on. So there's my 2 of my pieces, and then I've got 2 more of these to cut. I'm going to keep this scrap, and I'll show you why later. So then I just follow the same process. I'm going to put my clamp back here, square this piece up first. Slide it down to my flag stop. Move my clamp to the other side. And one more to cut. So those are the bigger parts for my cabinet. So now I need to cut 2 at 12 3/16. Same process. I've already got a square end to work off of. Use my clamp. So earlier we had a scrap piece that I said we're going to come back to. What this is going to be is the distance between my top rail and the bottom rail for my drawers are gonna go. I measured it out. It's 114 millimeters, about 4 3/16 is the opening. So if I had to line that up with my laser on my Capex, I'm entirely way too close to that blade. We've all done it before. We've tried to get that 16th or 32nd of an inch taken off of that small piece that we only have one left to do, but it's just not safe. So I'm gonna show you a safe way to do it with the Capex. So I've got 2 scraps of wood. The one on the bottom has to be the same thickness as the piece that I'm cutting. I'll take the other one and just form a bridge between the two, assuring that my line's lined up with my laser. Clamp that down. Now that's in there nice and secure, and I can make my cut. I have a small piece and all my fingers. All right, for the spanners and the hanging rail, we're gonna follow the same process as we did with the face frames over at the Capex. I've got my cut list there. Set this piece to the side, make some cuts. So the first ones, we want 2 of them at 29 inches. Square up the piece first. Change to my next measurement. All right, so we have all our parts and pieces cut. Only thing we have left is the back panel to cut. We'll wait to cut that after we dry fit everything to make sure the measurements are correct. Now what we want to do is put the dado in our side and upper panels for the back panels. All right, so we've got all of our panels cut, we've got our face frame cut, we've got pretty much everything cut for the cabinet. Everything's ready to go. Now we need to think about down the road when we start doing our assembly. Our back panel is just going to be 1/4 inch Luan. So it's a simple product you can cut down to fit. We're going to cut it to size after we dry fit the entire cabinet to make sure it's cut the proper size. If you haven't already, now's the time to label your parts. I've got my bottom of my cabinet, and I marked the left and the right side. I've got the side of my cabinet, right side bottom, left side bottom. Then also mark your front and your back, or where your face frame is going to go. That way you know where you're going to have your groove or your dado for the back panel. So let's talk a little bit about what a dado is. We've got our hanging rail right here. Hanging rail goes on the bottom towards the back of the cabinet. Then we're going to have our back panel. So you don't see, when you're hanging your cabinet, you don't see the wall that it's up against. That back panel will fit in a groove or a dado that we're going to cut on the bottom and the 2 sides of the cabinet. It's going to be about 1/4 inch or 6 millimeter wide and about 9 millimeters deep. And we're going to cut that all across the length of the bottom of the panel. We have several routers we could use to cut this dado in this panel. The one I'm going to use today is the MFK 700. Along with the edge guide, it allows us to make very quick and easy dados. I'm going to take the base off, and I already have an 8 millimeter bit installed in the router. The material we're going to use is 6 millimeters, so that gives us 2 millimeters, or a small gap, allow for that panel to move back and forth. So to install the edge guide, I'll take, like I said, I took the base off the router, lock that in, lock that in. I'll loosen all these other ones, except for that one. One thing that sets us apart from everybody else is there's actual center lines on the router itself, all the way around. So once I have the center line of my dado, I can put this on here. I can get it close And then I have a micro adjust dial right here. And each time I turn that dial, you can see that it's slowly getting closer to that pencil line. Once I have it dialed in, I can lock everything down. Now I'll just put the router motor back in the base. Tighten this down. I'll tighten this down. Now I've already got the depth set. The way I set the depth is I just glued a couple dominoes together. I know I want a dado into the board 9 millimeters. So I've got a 5 millimeter tenon and a 4 millimeter tenon, where I got that set at the perfect height. So I'm not trying to measure with my tape or my folding rule from the base of the router to the tip of the router bit. That's the perfect height each and every time. So once I have the base back on the router and the edge guide set up, I'm going to talk a little about holding the router. What a lot of people want to do is they'll grab it like this. Once they turn it around, they'll try and push it through. There's too many chances for it to tip in and out, and then you get a curved line. What I like to do is I'll hold the edge guide right like this. Once I turn the router on, I'll put my other hand here, and you've got 2 hands on the router at all times. So now with the dado cut, dust-free I might add, you can see where my hanging rail fits in here. My back panel will slide down through there. Now I can run a screw from the inside of the cabinet, through the back panel, through the hanging rail, securely into the wall. Now that I've got the dado done on the back of the panels, we can focus on the line boring for the shelf pins and also the hinge holes. I'm going to be using the LR32 system, which consists of the LR32 rail. It's just a 1400 or 55-inch rail that has holes bored in it that are 32 millimeters apart. That'll also work with the LR32 system for either our 1010 router or our OF 1400 router. Today I'm going to be using the 1010 router. 32 millimeter system is one reason that I still work in the metric system. I cut these panels so they are divisible by 32. That allows me for a lot of different things, but allows me to use this LR32 system to drill my shelf pin holes. On the guide rail, we use these stops, and there are several different numbers on there, so it gets a little confusing, but for this setup, I'm going to have the 32 facing up, and it's going to be away from my material. I've already got the one down there set. I just place this one on the bottom, put the screw in, and because I cut it exactly 32 millimeters, it fits nice and snug. Now this way, when I go to drill the holes back here, I can flip my guide rail around and all the hole spacings are going to be exactly the same. So now that I've got the guide rail centered on the panel, basically, now I need to figure out how far off the front edge I'm going to place my holes. And that's where these come into play. These are adjustable stops. You see right here, I've got it from 0 all the way up to 110 millimeters. I'm going to be setting these at 37 millimeters. So it just slides on the rail like that. And we have another one down here. And then I can just push my rail back to those line up. Now I know those holes are going to be perfectly parallel with the front of my cabinet. This is one area you definitely want to clamp the rail down to your material so it doesn't move on you. On the router itself, I've installed a 5 millimeter spiral brad point bit. We also have another bit available for it. It's a flat bottom through cut bit. So we can cut all the way through the panel if I'm doing a center panel. I have the depth set to about a ½ inch. So it'll just bore down to about a ½ inch. And that allows for the shelf pin holes to go in and also the screws for the hinges. So now that I have the guide rail in place, I can remove my stops to clamp down, and I can focus on where I'm going to bore the holes. Now on this guide rail, I've went ahead and marked where my screw holes are going to go, and then I've got 6 shelf pin holes in the middle, because I don't need shelf pin holes all through the entire cabinet. So when I put the router on here, there's a little viewing window. That's got an arrow right there. So I can see exactly where I'm going to drill. I'm not guessing. Before we get started, there's a couple things you want to do as far as placement of your hands on the router itself. Once I have the router on, I'll lock it in place, lock the trigger in place. Then I always have two hands on the router. My left hand will be down here, and this controls the pin action. So as I push that down, that pin in here raises up and indexes on the next hole. Very quick process. Then all I have to do, because it's a plunge router, is just push that down and it comes back up. I also keep my hand underneath the cord and the hose just to keep it up and out of my way. So let's give it a shot. So I've gone ahead and I've flipped around this first panel. I've got my holes drilled on the front of the panel. Now I've got to drill the holes on the back of the panel. Now, if I just went 37 millimeters from the front of the panel back here, my holes are going to be extremely close to this back panel. So what I want to do is I'll just keep this set at 37 millimeters, but instead of referencing off the back edge of the plywood, I'm going to reference off that dado that I put in earlier. So now I'm 62 millimeters from the back to that line, or 37 millimeters from that edge to the center of my holes. Make sure you note to yourself, don't drill these holes on the back side of your panel because you don't need hinges on the back side of your panel. So I'll just drill the center 6 holes. So now that I've got the right side done, I'm going to come back over here and do the left side. The good thing about the Festool system is once I set it up one time, I can do 5, 10, 20 cabinets and they're all going to be the same. So let's get started. Finish up this side of the cabinet. I just have to do the center holes and then we'll be finished. So what I typically do is I'll just kind of look at the grain, decide which side I want faced out, what side looks better. Once I get those all sorted out the way I want them, then it's a matter of deciding how I'm going to join these together. So what we're going to use is the DOMINO DF500 loose tenon mortising machine. And it uses solid wood domino tenons. We have these in different sizes for different types of material, different thicknesses of material. The size we're going to use today is a 6x40, so it's 6 millimeters thick, 40 millimeters long. So first thing I want to do on the domino itself is change out the cutter that we have in there. To do that, we have a wrench that comes with the domino. Let's pop that up. That comes out. Then on the side, we have a spindle lock. I'll just pop the 5 millimeter cutter that I have on there. Take that off. And then put the 6 millimeter on there. So the diameter of the bit determines the thickness of the mortise that we're going to be making. And then I'll show you what determines the width here in a second. Now when you go to tighten that bit, don't over tighten it. Just snug it up, because as you use the machine, it's going to tighten itself down. And then just push it all back together. So the way this bit works is it spins like a drill bit or a router bit, and it oscillates back and forth. That is what's going to determine the width of our mortise. So the length and the diameter of the bit determines the thickness and the width of the mortise. Next, I have to determine where I'm going to place the mortises in the face frames. The Domino is very easy to use because it has reference points on the machine itself. So all the accuracy is in the machine. These reference points are exactly 37 millimeters from the flap to the center of the mortise. So if we look here closer, the Domino will set that mortise centered at 37 millimeters from one of these edges. So if I measure here over 37 millimeters, approximately right there. Now my tenon is 20 millimeters wide. So if I go 10 millimeters on either side of that mark, right there and right there, you can see how close that's going to be the outside edge. That is way too close to that edge. So we have another option. The Domino comes with the support foot. The support foot has two more reference stops on it as well. These will place the mortise 20 millimeters from the edge to the center of my mortise. So that's what I'm going to use. Installing the support base is pretty simple. I just put the fence up on the Domino, and on the bottom there's two threaded holes. I like to install it in this fashion. I'll show you why here in a second. So if I was just to lift it up and try and put it in here, there's some slop in the base. So this keeps it perfectly flat and even with the front of the Domino. Now you can see these two flaps, they register off the 37 millimeter flaps. That gives me 20 millimeters from here to the center of my mortise. So once the Domino is about set up, we want to think about how we're going to make these mortises and all these pieces. The biggest key to the Domino, no matter what you're using it on, if you're building a table, a cabinet, whatever you're building, is label all your parts and pieces. So you don't get turned around, you don't get confused. I mean, what I do is I'll just go around and mark A, B, B, so on and so forth, all around the entire piece. Then I also want to think about where the mortises are going to go. So in this corner here, I have two spots that I can reference those flaps off of to get me 20 millimeters to the center of my mortise. Right here, I've got a reference point that I can pull off of, but on this board I don't. So what I'll do is use these blocks that we cut earlier, 114 millimeters, they're just spacer blocks. I'll get those lined up, and then I'll just take a straight edge of some sort and go approximately center. It doesn't have to be exact, I just like it close. Now I've got two lines to put a mortise in there, that I can reference off of the Domino machine itself. So I'll just walk around and do that to the rest of the pieces, and then we can get started mortising. So when I go to lay out my mortises for my center style in the cabinet, on the bottom, I don't have anything. I can do some measuring. The more I measure, the more I have a chance to make a mistake. So I'm just going to use my face frame for the underside of the drawer, move that down, butt it up tight against that side, push that over. Now I know that is going to be the same as up here, even if my board has a slight bow to it. Take my straight edge, get myself a center line. One thing I always do before I'm using any woodworking equipment is double check my settings. If I look down here, both of these two settings are off. This is my board thickness gauge, so this is how far from the plate of the Domino to the center of my mortise I'm going to be. Basically, where that mortise is going to be in the material. I want that at 20. My material here is about 18 millimeters. So at 20, that's going to get me close to center, which is going to be fine. And this is how far into the board I'm going to make a mortise. I want that 20 as well because I'm using a 40 millimeter long tenon. So I'm going to do half and half in each piece. So for the first mortise I'm going to reference off of one of my 20 millimeter reference points. So I just reference it off the corner, rotate it into place, make sure I've got firm pressure on my T-handle. So on this piece, I'm not going to use any of the reference flaps. I'm just going to use this line as a reference point. So I just find that line, with the line on the domino itself, and then I can make a mortise. Reference point is very important with the domino. I'm doing both ends of this with a mortise. And if you noticed, I was flipping it around this way. What some people will do is they'll flip it like that and they won't think anything of it. What I just did is I just changed my reference point from this side to this side. If you remember, we had the depth of the mortise from the fence down at 20 millimeters. This material is 18 millimeters. It's 2 millimeters difference. So if I change my reference point, when I put this piece back together, it's going to be sitting crooked. So I'll have a 2 millimeter lip over here and a 2 millimeter offset over here. So always make sure you reference off the correct face. All the mortise is done, we can start talking about doing a dry fit. I always do a dry fit. I don't care how accurate I think I am. There's always that chance for a little bit of mistakes. So no glue first, but you'll need a couple tools to get this started. I always like to have a good pair of side cuts or pliers around, a hand sanding block, and a little hammer to tap the dominoes in because they are a tight fit. These dominoes are very precise. The machine's very precise. It's designed to be tight. If you look at the edge right here, there's a little raised groove. And that groove is just a slight bit wider than the actual mortise itself. That's for alignment purposes, make it nice and snug. What I do is I'll get a hand sanding block and I'll just lightly sand down that groove so there's no groove on either side. So when I do a dry fit, it slides right in. It doesn't affect the alignment. What I don't want to do is sand it this way. Take any width off the thickness. All right, let's get that started. That's what I've got my little hammer for. For the center one, what I typically like to do is I'll get the end started and slowly wiggle it in there and then tip that up at an angle and I can bring it all together as one piece. And that's going to be really important when you go for glue up to get that lined up correctly. Looks like it turned out pretty good. Next step is glue up. I get questions all the time on how to glue up for mortise and tenon, for domino mortise and tenon. Do you put glue in the mortise? Do you put glue on the tenon? What I typically do is I'll put glue on the tenon itself. If you look at the face of the domino, there's cross hatches all over it, as well as grooves on the edge. When I put glue on that and then put it in the mortise, that glue will spread up the tenon itself, and then it'll squeeze out where you've got the two pieces connected. It gives good coverage over the entire tenon itself. Then I just put a little light clamping pressure on there. Once I get them all lined up and glued up, wipe off any excess glue, let it sit overnight, and then you're ready for sanding. So now that we've laid out where our panel is gonna go, we're gonna lay out where our mortises are gonna go exactly. What I always like to do is I actually draw a circle where each and every mortise is gonna go. So I know I'm gonna be putting a mortise into there. If I flip this panel up, you can see I've drawn circles there. I'm gonna put 3 mortises and 3 tenons in each piece. Now to figure out how I'm going to get those mortises correct, if you look, When I have that laid out, this is the inside of my bottom panel. It lines up with that pencil line. If I fold it down the other direction, I still line up that corner of that face with that pencil line. It's right where that panel is going to go. When I take the domino in here, now the base of my domino is going to reference off the side panel. And when I flip it up in the vertical position, the base of my domino is now going to reference off the bottom of my base panel. And then I'll make sure they line up perfectly. All right, so about ready to make a mortise. I've changed the cutter in here to a 5mm cutter. We're going to be using a 5x30 tenon. Changed the depth of plunge to 15mm. I don't have to worry about the fence because I'm referencing off the bottom of the domino now. So let's make a mortise. So when I go to do the next one, because I marked out the center line on both these pieces, I'm using my eye, my tape measure, my pencil, there could be some variances in there. I already have a mortise that's gonna give me alignment here. So what I'm gonna do is there's another switch on the top of the domino. This controls the width of the mortise. Right now it's set at a tight setting, so it's gonna cut exactly 20mm wide, the width of the mortise. If I set it to the center section, that's going to add 3/16 to the width of the mortise. That's going to give me some wiggle room or some play. This other one is about 3/8 wider. That's for a breadboard end, which we can talk about much later. And make sure that you only turn that dial when the machine is turned on. For this last mortise, I don't want to reference my flaps off the edge, and I don't have something to line up with my center line. If I reference my flaps off the edge, that's going to bring it in 37mm, which is going to put me very close to that dado. So what I'm going to do is just line up the edge of my domino with the edge of my plywood and make my mortise. All right, let's see if it fits. Perfect. Flush here, I'm right on my line there. All we have left to do is mortise the other side to the bottom. So now that we've got the bottom onto this side, we can flip it over, put the other side on, then we can get a measurement for our back panel. So next thing I want to do is get a measurement for my back panel. It's two ways you can do it. I know the bottom piece of my cabinet is a set dimension. I can measure that exactly. I know the depth of my dado is about 9 millimeters on each side, because that's the depth I set my plunge. So I can measure the full width of my bottom piece, add 18 millimeters, that would be exact size. I want to leave a little bit of room for that panel to slide back and forth, so I'll take off about 2 millimeters. The other way I can get a measurement is by measuring the bottom of my dado here over to the bottom of my dado here, because I've got a fixed measurement, and just subtract 2 millimeters. And we will install that back panel once we get everything glued up on the cabinet. So I want to show you another way you can put these cabinets together. We recently came out with the D8 connectors for the Domino 500. Essentially, they're just knockdown connectors. So there's several other connectors and tips and tricks for this set. If you go to our YouTube channel, you can find out more about it. The ones we're going to be using have a couple parts to them. So we'll make a mortise with an 8 millimeter cutter, and this wedge fitting will actually go into that cabinet like that. And then we're going to use this jig after we make another 8 millimeter mortise, just like we did on the last cabinets. We'll put that into the mortise we make in this panel, and then we'll drill a hole with this jig to accept this side of the connector. And this is just a pin style connector. We have a post that fits inside this connector, and then this little set screw is tapered on the bottom. So that taper fits into the groove of the post. And when I tighten that down, it draws the post in, sucking the two pieces of material together nice and tight. We can use it in conjunction with the solid wood tenons. So once we do get to the job site, we can throw a little glue on them, actually utilize these as somewhat of a clamp. So it'll pulls it all together, holds it together while that glue sets up. So let's get started. Before we start making mortises, I want to talk to you about how I changed the cutter on the Domino itself. It's no longer a 5 millimeter cutter, I put an 8 millimeter cutter in here. And I'm also going to change the depth of the mortise on the bottom panel. I'm going to be plunging in 28 millimeters on the bottom panel. Now when I switch to do my side panel, because I'm going to be doing it in the vertical position, I can't do 28 millimeters. If I do 28 millimeters, it's going to go through the side. So I'll switch that to 15 millimeters. So I'm going to start out with my 28 millimeters, and we'll make some mortises. So once I have the mortises done, the next thing I need to do is drill a hole for this connector. It's very easy. We have a jig that comes with the Domino connector set, and this right here is exactly the same size as an 8 millimeter tenon. So once I have my mortise drilled, all I have to do is make sure that fits in there, and then this locks that plate down. If I want to make sure it's very secure, I can also apply a clamp. Clamp that down, attach dust extraction to it, and put the supplied bit into my Festool drill. And there is a collar on here, so I can only drill it so deep. It won't let me drill any deeper. So let's go ahead and drill out the hole. So for the center mortise, I'm not going to use one of the connectors. I'll just use a solid wood tenon, because that'll allow me to glue it up in the field if I'd like to. So once I've drilled those holes, I can then install the connectors that'll accept the posts that we talked about earlier. Pretty straightforward. The one thing you want to notice is there's a line on each side of that set screw. That line needs to be parallel to your panel. So you just simply drop it in on both sides. Now we also have these black locating connectors. What those do is I'll slide them in from the end of the mortise, and they'll lock it in from keeping those connectors from falling out. So the next thing I want to do is install the expansion fittings. They simply just go into the mortises. This just threads in the expansion fitting. I'll tighten down as much as you can, and then we'll use a drill to tighten it the rest of the way. So I'll remove the bit and install a bit holder, and then just tighten it down all the way. So once it's tight, I'll have to loosen it up so I make sure that dished out part is facing towards the bottom of the cabinet. Then I'll just repeat the process on this side. So now we can do a test fit, see how it goes. Line up the pins and the wood tenon. Makes for a nice tight joint. I won't tighten it until we get the mortises and the hardware put on the other side, and then we'll lock it all together. So from this point, we can cut the back panel. We already got our spanners cut, our hanging rails, we can install those, and we can also install our face frame. At that point, the cabinet's pretty much done, other than a toe kick. If you noticed, I did not install or cut out a toe kick on this cabinet. What I like to do is I will build a ladder on the ground, I can level that up, and then I can set my cabinets on top of that, knowing everything is perfectly level from there. So we just did the dry fit of the cabinet carcass, knocked that back down. Now we need to get to sanding. We're not gonna have to do a lot of sanding on this. This plywood came pre-sanded to about 120 grit. So all I'm basically doing is just knocking down the pencil marks, getting those off of there. To do this, one thing you notice, I don't have the standard quick clamps that I had out earlier. I'm gonna use these clamping elements. The clamping elements go in the dog holes of the MFT, and then we have the clamp part of it over here that locks it into place. Now I can sand the entire piece of plywood with no clamp getting in the way. So the sander I picked is the ETS EC 125/3. A lot of numbers there. 125 stands for the diameter of the pad. It's about 5 inches. Now the 3, what that stands for is the size of the orbit of the random orbital motion. So it's a 3mm orbit. The reason we chose a 3 versus a 5 is the 3 is less aggressive. And with sanding on veneer plywood, the veneers are getting thinner and thinner each day, so I don't want to sand through that veneer. Just want to sand pencil marks off, knock down any high spots, and then at the end I can put a finish on it. So the grit I'm using is a granite abrasive, and it's a 120 grit. So let's go ahead and do some sanding. I want to talk a little bit about how to sand. A lot of people think, oh, you just sand until the marks are gone or the high spots down. I always like to keep the sander moving. If you notice right here, I still got a little bit of this pencil mark left. I don't want to just keep my sander here and just move it back and forth in that one area, because what's going to happen is I have a chance of sanding through that veneer or creating a dip if it's a solid piece of wood. Always move. If you only have one spot you have to get down, sand the entire piece so it stays completely even and flat. You don't have a chance of sanding through the veneer or creating a dip if it's solid wood. And we're down to the last panel for this carcass. Okay, so we've got the carcass all sanded down. Now we can start working on the face frame. I had this in clamps overnight, just pulled it out. So we need to come back and sand off all the pencil marks and get rid of some of the glue that I didn't get off when I wiped it down. I always try and wipe down all my glue ups after I put them in clamps. So there's a little bit left over. I'm going to switch over to 80 grit on the sander from 120, because we're going to sand a little bit more coarse. So I can get this in clamps and we'll start sanding. Got the front pretty much where I want it with the 80 grit. So what I'm going to do really quick is just flip it over. Just get the back side, just try and get some of that glue off there. Nobody's ever going to see this, so it doesn't have to be perfect, but I like to sand and make sure it's all flat. So now I've got both sides sanded to 80. I'm going to flip it back over to my face side, clamp that back down, and I'm going to take this up to probably 150. So we'll put 120 because we're going to jump up to 150, and that should be the end of the sanding. Okay, now that we've got everything sanded, we're ready to glue up of the carcass. I've got my hanging rails, my spanner, my 3 panels. Then once we get the panels done, we can install the back panel. I'm going to use the spanners and the hanging rails to kind of lock everything together while that glue dries and sets up. So now we've got it glued up, the dominoes are in. I'm going to run a couple screws through the side panel into the bottom panel. This is going to be a sink base, so it's going to be surrounded by other cabinets, so those screws will be hidden. I'm going to go ahead and put a countersink and counter bore bit in to drill these holes. After I've got the sides attached to the bottom, I can focus on putting in the hanging rails and the upper spanner to lock it together before we put the back panel in. Next piece I'm going to install is this top spanner. Now when I cut this, I cut it the exact same size as the base of my cabinet, this bottom piece. So that way when I put it in the top here, it makes this distance the same as this distance. But it won't hold itself in place, so I'm going to go ahead and pre-drill the holes first, then I can run the screws in while I'm holding it in place. So with all those installed, now we're ready to install the back panel. I've got the back panel, I cut it down at a 1/4 inch Luan using the TS55 and the guide rail. Now we'll just get it installed. With the carcass all assembled, the last step of the process is to attach the face frame. To do that, we're going to utilize the domino. A lot of the same processes as we did when we assembled the carcass and also the face frame itself. Let's get started. So the dry fit's complete, everything fits nicely. I can take it back apart, throw some glue on the dominoes, clamp it up, and then our base cabinet is finished. So with it all in clamps, let that glue set up overnight. After that, you can take the clamps off. Look for any spots you may want to touch up, sand, any pencil marks left behind, any glue that might be there. From that point, it's a matter of just measuring for your doors and drawers, but this cabinet is finished. So now that we have our base cabinet with the face frame finished up, we can focus on our upper cabinet. We've already cut the panels down to size. We've added our dado. Next thing we have to do is apply edge banding to the front face. To do that, we're going to use our Conturo KA 65 edge bander. It's a portable edge bander that can do straight runs as well as inside and outside radiuses. If you want to learn more about how to use this, how to set it up, visit us on YouTube. You can watch a lot of content on the Conturo as well as a lot of other tools and applications. So for this application, rather than using the quick clamps, I'm going to utilize the Vaxxis vacuum clamping system. Works off a vacuum pump, also has a foot pedal, so when I put the material on here, it sucks it down to the suction cup, and then when I'm ready to flip it over and trim the top or bottom edges, I can hit the foot pump, flip it over, suck it back down. For my specific application, I've built a holder for the side of the MFT. If you don't want to build a holder for it, you can also utilize the holes in the MFT to put our clamps in there, hold it down, works just as well. To use the Vaxxis, it's very simple. Take the supplied air hose line, hook it up to the vacuum pump, turn the vacuum pump on, adjust the head to the position that you'd like, and just put your material on top, let it seat, and it's locked into place. So I've gone through and I've set the Conturo up the way that I want to use it for this application. I've put in the edge banding, pre-cut to length, installed the glue, the natural glue puck, so we're ready to go. So once I've applied the edge banding, it cools to the touch within about 15-20 seconds. Then I need to trim the ends. To do that, I'm going to pull out the edge banding trimmer that comes in the Conturo edge banding set, or it can be purchased by itself. This is a guillotine cutter. Simply feed the edge banding in through there, squeeze the green handle, and it'll trim the edge banding. Now that we've trimmed the ends of the panel, we need to trim the top and the bottom. The reason we run these wide is so we can trim it so it's perfectly flush. There's manual hand methods you could use. I choose to use the MFK 700. It's quicker, it's more efficient. It's the same motor that I used before when we were doing the dados. I've just replaced the base with a 1.5 degree angle base and a straight bit. You can see how fast and efficient that is. Once I have that one done, I can just breeze through the other three and we'll have this cabinet together in no time. In a matter of minutes, we have all four pieces edge banded, trimmed, ready to go. The reason we did the edge banding before we put in our mortises for the assembly and the shelf pin holes is because that edge banding adds about 1 millimeter to 1.5 millimeters of extra width. If I put that on beforehand, that could throw off where my dominoes are placed and my LR32 holes are placed. So for this project, we used natural color adhesive. We have several other different colors of adhesive for the Conturo, for different types of material, different types of edge banding. The reason we use edge banding is on this piece of plywood, typically you don't want to see the end grain of a piece of plywood. You can see all the plies, it's not that attractive. Also, plywood is much more rigid and stable than solid woods. If I built a full cabinet out of solid wood, there's more chance of it to move over time. Plywood is much more rigid. From that point, it's a matter of just measuring for your doors and drawers, but this cabinet is finished.